Hello, my name's Evan, and I'm here at Sarah Laser. I'm going to be demonstrating for you the LightBot. The LightBot is an integration that we've done here at Sarah Laser using the Fanuc CRX collaborative robot series and the LightWELD handheld laser welding system. So I'll kind of move this up and out of the way so you can see it a little better. The one that I have right here is the 25 kilogram model. It's the largest of the series. So you can kind of see the size of it if I stand over here next to it. It's a pretty big co-robot. It has a good reach. There's also smaller systems such as this one that's laid over right here. I put it down to get out of the way of the camera, but this is the 10 IA. So this one is the 10 kilogram system. But yeah, the one that I have running today is this 25 IA. And so right now I have just a LightWELD XC 1500 XC mounted on here, and I have the wire feed set up. I can do fusion and wire feed. I can switch that very easily. Um, and yeah, so do you guys have questions about the system? I understand you might already have light welds, and you just have some questions about this setup.
I think one of the things we've been seeing is just the difficulty. So take an example of butt weld, where you've got to sit there and follow that by hand. And there's, in reality, it looks great on a demo to stick a guide on the side of it, but that's not what we want. So we're looking to really be able to harness the ability to go point to point and set up our weld parameters that way. And I think also one thing I'd like to understand a little bit better, some of your videos on the fusion welding on, say, I think you did some aluminum fuel boxes. Just understand how in reality, how well that works and how functional that is. And then maybe pluses and minuses on the smaller robots and the larger, because everything we do is pretty big. So we're assuming we would go to the large, long reach.
Okay. Yeah, honestly, anything that's especially if you're doing like box type structures that have, the robot's gonna have to hit angles on multiple sides of it, you're gonna want the long reach. The short one is real good for small components, like, if you're doing like small linear welds or if the components are really small. But consider that when the robot reaches over here, the entire arm has to get on that, or part of, this end section of the arm has to go beyond the part and then reach back to get the gun to the proper position. And also, if it were to go here, same on all sides. So when you start going around like a box type deal, or like a radius where you have to go around something like this, the long reach becomes much more important. When we have people who are just doing like small spot welding applications, the small one tends to be good. But for like for reaching around a part, anything bigger than like this, you're probably going to want the larger one. But yeah, so sorry, go for it.
Oh, I just maybe generally just go over how it's programmed and how that's set up to work with how they can relate to it by their hand light welding.
Okay. Yep. Yeah. So sorry.
We do have robotic welding here, so we're used to normal robotic welding and programming, if that helps at all.
Okay. Awesome. Yeah. So yeah, that'll help a lot actually. Really, the main difference is how the light weld, as you guys know, the light weld, it travels. Your joint needs to be kind of in line with the gun, right? You don't really go like with a MIG welder, I may go sideways, right? But with the light weld, you always go in a line. So with a MIG welder, you kind of have the flexibility to move the torch. The torch will weld the same no matter what orientation it's in. The light weld has to maintain its proper angle throughout the weld. So that kind of brings the reach down a little bit in some situations. I'll show you. I'll just kind of program this and I'll show you how this is going to go, and maybe you can get an idea of how you'd be using this, and then maybe even though I just have this one joint set up here, maybe I'll kind of act as if I was gonna weld a joint over here, and you could see the different reach and all that. So let me zoom in here. Okay, let's see if we can get this to go sideways. Okay, so I'm gonna make a new program here. This screen that I'm on is on the teaching select program area. And then it shows a list of previous weldments that I've programmed. But I'm gonna click new. What's the name of your company?
Metal Solutions.
Sorry, what solutions?
Metal.
How do you, sorry, it kind of cuts out like really right when you start talking. What is how do you spell it?
METAL.
Oh, Metal Solutions. Got it. That's easy. Okay, so I'm just gonna make the name here. Metal Solutions demo. Okay, and then it's gonna ask me if I want to make a comment, and I can do write protect and stuff from here. Select a few different modes if I wanted to avoid singularity or not. So I'm just gonna skip those, click OK. So the way that this is gonna work is that I have this, timeline. It reads like a book left to right, and then it'll drop down. And I'll use these icons. I'm gonna switch it to this way. I think it's a little bit of a better look. I'm gonna select from these menus in order to find commands that I want to use. So if you go to my history, this is kind of all I use to program typically. You can definitely get a lot more in depth with it, but I tend to keep my programming very simple. So as you can see, I have a laser on command, linear motion, comment, just so I can keep track of where I am in my program, joint move, some laser off commands. There's two of them. I'll get into that a little bit later. A wait, circle arc, set program. Set program is going to be the one that's essentially mimicking you going to the front of the light weld and setting your mode. And then a weld point circle, which you can use circle arc or just normal arc. I was experimenting with this weld point circle, which is, it does the same thing as a normal arc command. Okay, so yeah, this is kind of all I use, but if you want to go here into the plugin menu, you can see all the icons we've developed specifically to control the LightWELD with the Fanuc. So we have icons that have to do with your basic laser commands, like firing the laser, turning it off, setting your program, adjusting your power. You also have ones like if you look here, the WP1, WP2, WP3. These are weld presets that you can develop. So similar to the LightWELD, how you can, save a preset and then just, use that 2-digit code to go there. This one makes it even easier, where you can save a specific weld preset in this icon, and then when you drive it up there to the timeline, it'll just call for that program. So if what you're doing requires, like, let's say there's 5 overall settings that you use when you're welding your parts with this, you can just make all your settings into presets. So when you get to that point in your programming, you can just drag up that weld preset. So these are our icons we've developed. So as you can see, you can get more complicated with it. A lot of times I just try to keep it simple, but there's definitely a good use for a lot of these in certain situations.
Hey, could you highlight one of those just to show them what goes into that so they can see?
Yeah, I don't have the weld program set up right now, so I'll use a different one. But let's do set program, and then I'll show you the laser on. So set program, I'll highlight it. It'll go to the details. And then just like the front of the light weld, let's say I'm welding, I'm not sure which light weld you have, but stainless steel wire welding condition for this light weld is going to be, for this material that I have, is going to be maybe A7 or A8. So I'll click A7. So it's just going to call up the factory preset A7. Now, if I want to change the power, I can click override power, and then I can manually enter the power that I want to use. just like on the front of the LightWELD. You know, you go to the preset and then you adjust the knobs. Same with wobble frequency and wobble length. Now with the laser on icon, you can adjust how long the robot is going to wait at the beginning of the weld for the gas preflow. So the gas preflow itself is set up in the setting, but you can tell the robot to wait for that or not. You can also tell the robot how long to wait for the ramp up. So if the laser ramps up over the course of 1 second, but you only want the robot to pause there for 1/4 of a second, you can do that, or you can match the ramp up of the laser on. These are the defaults here. These just pop up as this automatically. If I want to use a wire feeder, I'll select use wire feeder. And then I'll select, right now we have our new wire feeder that we produce here, called the LightWire. So I'm going to go to that, and then I'll set my wire feed speed, let's say 65 centimeters a minute. I can also use these two at the bottom, auxiliary device, in order to activate additional devices. So for instance, if I have a rotary or some other device that can just be activated with like turning on a relay, I can wire into the robot to send a 24-volt signal to a relay, and then that relay will then control the on and off position of whatever device you have set up. So that may be a fume extraction system, that may be a rotary device, that may be a additional source of shield gas if you're working with a highly reactive material. And we use it a lot for like spinning rotating devices. We just, we'll turn it on and have it spin during the weld and then turn off. And yeah, so you have two options for the auxiliary device. It's pretty simple to wire up. You just wire, 2 wires to a relay, and then power to the relay and power to your device.
Maybe explain how that fusion lock, that one works.
Yep, that's where I'm going next. So, yeah, so then let me zoom back in here. Okay, so I had the wire feeder selected here, but I'm not able, when I choose the wire feeder, you'll notice that the fusion lock here is disabled. So let me disable the wire feeder, and then it allows me to select fusion lock. So what we found with this system is that making touch continuity on complex geometries is very, very difficult. So we've developed a way which you can select here. There's also a mechanical switch that you have to turn on to allow that in the first place, where you can weld without touching the part for fusion welding. For simple geometries, it can be just as easy to drag the nozzle on the part and use force control through the robot to like have the gun push down on the part. But when your geometries become quite complex, it becomes nearly impossible to fusion weld while touching the part. Even by hand, some geometries are very tricky to follow the contour by hand. So we found a way to allow no contact welding with the system. And you are basically selecting that, saying that that it's not going to touch, and basically what you'll do is you'll program the start and end points or any of your weld positions with the full length nozzle, so that you get the correct focus distance. And then when you go to actually run the program, you'll remove the spacer or shorten the nozzle in some other way. And then the weld program will go along just a very small amount of distance off the surface, so that you can make complex geometries doable. So that's the fusion lock there. So you'll activate it on the laser on, and it'll automatically turn off that capability on laser off. So there's no chance of somewhere else in your program while you're doing an air move of the laser being firing. So it's on laser on and off at laser off. Yeah, so that's kind of that's kind of how the programming works. It's really, really simple. Just drag and drop icons. I can rearrange icons. Let's say I dragged something in the wrong position. I'll go right back here again. Let's say I had, put a linear move and then I try to do another one, but I don't even know where it went right there. It kind of, I dropped it without looking at it closely. I can do undo. It'll undo my last move. I can, precisely position them in between other icons. If I want to copy and paste this one, click and hold, copy, paste. I can do delete. I can also change a linear move. Say I realize that one needs to be a, maybe the first move of an arc. Choose arc. And then any of these positional icons, I can click here. It'll tell me the data of its position. I can always move to, so I can just drag this over, and the robot, wherever it is, it'll move to that point so that I can, check my accuracy on it. And then if I need to make an adjustment to it, let's say that the Z, it's like off by, I don't know, 2 millimeters in Z. I can either move the robot manually. Oh, that was a mistake. I can either move the robot manually and then click touch up and it'll override the data, or I can manually change the data. So I change 2 millimeters there, and then I can click touch up. Okay. And it'll, now be saved with the altered data there. So any of these icons I click on and it brings up this details. I can also make those go away. I can completely collapse this menu so I get a more full view. And then I'm going to populate it just randomly here so that you can see what happens when I go past this first line. Initially, the software had you having to scroll sideways in order to see the whole timeline, but it became easy to accidentally grab an icon and drag it. So they've changed it now to where it'll drop down and it'll just keep populating vertically. And then this also translates to on your sideways. Any questions about kind of how this part works here?
Real quick on your fusion, when you do the offset, can you put that in the middle of a program? So, or do you, because you said you have to take out that spacer, you wouldn't have to stop welding to do that. It would know what distance it's supposed to step back automatically, correct?
You need to teach it at a certain distance for the focus point, and then when you run your program, you'll just run it with that spacer retracted. But again, this only works for the fusion lock, only works for fusion welding, and you only need it for fusion welding.
Right.
So when you're going about your program, you wouldn't have the wire set up on there anyways. With the wire welding, it uses the continuous feed of the wire to make that constant contact with the part. So the wire feed will, is constantly feeding and basically making continuity into that molten puddle. So you don't have, the difficulty. Let me kind of explain it a different way. The reason that the fusion lock is difficult, or sorry, the fusion welding on complex geometries is difficult, is because, where are you? There you are. Is because the tip will touch the surface here, but the laser is touching the surface here. So on a straight line weld, that's no problem. But when you have to go around a contour, what you'll notice is that where this touches is not where you want the laser to hit. And so it'll it's difficult to get it just right. So that's why what you do is you program it with this. You teach it its distances with this, which is at the TCP. This just screws on to the end of your light weld like that. So you'll program it with this, and then you'll switch it out for this when you're actually running the program, and you'll see that it's lacking the spacer, or you can put the shorter spacer on. And so then when it actually runs the program, the nozzle will be about here.
Yeah, I saw that on the video and it makes sense, but that was one of the things we were having difficulty with was since you have to have constant touch. And I had seen on one of your videos, I think you put on, looked like a brass brush on the side.
Mhm.
I figured it was
Yeah, that was a while ago. That was our first solution to trying to figure this touch contact out. And we've tried various things, but the easiest way is the way we've done it, which is incorporated into the laser on, laser off icon. There's we just have a way of telling the LightWELD basically that it is touching during that weld part of the program. And yeah, so this is the most accurate way. Also, when you're not touching, you don't have the risk of, crashing the nozzle as easily. So let's say you programmed it wrong and it's going around this corner and it clips this piece of metal. Then if you were to, crash hard enough, it's possible to, obviously bend tooling and stuff, or, move your fixture and then you're stuck with reprogramming everything possibly. So what's really nice about the no touch is that you have a lot less chance of crashing into the part. You have the ability to weld more intricate geometries, and you don't have to worry about trying to maintain continuity. Let's say you're welding around a really tight radius. Well, the robot moves pretty smoothly, but if you're going fast around a radius, at the length of the robot arm still has a chance to have a very small amount of vibration, right? And that little vibration can leave the surface and that would cut off the laser because that's just how that LightWELD is designed. So yeah, we've made it pretty seamless in order to make consistent, successful welds. I think we've been working on this for, I don't know,
2
maybe
years
it's been
now. Yeah, just
yeah,
a little over 2 years. Yeah.
2 years, and we've made a lot of really good improvements since that video you've seen with that brass brush on the end. We've made some drastic improvements. That was just early on, just figuring it out. Yeah, now it's pretty smooth. It goes really well, and it's nice and easy to program, especially with all these icons that we've got going. It's just like, it's really good if you know how to use the LightWELD, right? Because you know how the LightWELD needs to move. And then with the robot, we're essentially trying to simulate the same type of movements. And the way that this Fanuc is set up with the timeline, being able to see all of your program. Some of them, they're vertical, but they're one line is one command, right? So then you have to scroll down, especially once you start adding a bunch of commands. This one, since it'll populate, you can fit so many commands within this screen without having to swipe to see. It's really nice to kind of be able to get it's really easy to program this is what I'm trying to say. Any other questions about any of this before I go ahead and maybe do a weld? All right. Okay, so what I'm gonna do is I'll kind of show you what I have going on here with this fixture. Are you guys fusion welding mostly, or are you using the wire mostly?
mostly water.
Either one?
Mostly with the wire.
Oh, wire.
I
Okay.
prefer the fusion because I think it gives us a better finish on it, but yeah, we cover both.
Okay. So yeah, I can do an example of both also. I have the wire set up now, so I'll start with that. The wire, it's really easy. You gotta just figure out the wire speed. So maybe after a couple test parts, you'll know exactly what wire speed you need to use at your travel speed. Typically, you just start off by matching the wire speed to the travel speed, and then you might have to bump the wire speed a little bit faster, just depending. Sometimes it's better to have a little bit more feet of the wire than the speed that you're traveling. But yeah, I'll kind of show you what I've got going on here. It's a really simple fixture, but it demonstrates, an outside corner joint. This is another thing to talk about with the robot. Obviously, you guys know you have welding robots, but accurate fixturing is really important. So I just made this very, very simple. Right, so I have these plates that just sit there, butt up against this guy, and I'm just using binder clips here. I have noticed that these binder clips aren't quite strong enough, so sometimes the part will distort a little bit. Probably should have used something more substantial, but this will work for the demonstration. And I'll put it right about here. Clamp it down. Thought about programming all this beforehand and just showing you the weld, but I want to show you how I go about doing it. Okay. Sure the parts are square on the fixture. Okay, so what I'm gonna do is just go ahead and delete all of these icons here. Okay, and what I typically do is I typically start off with setting my weld program. I know what material I'm working with. I know that I'm gonna use a wire, so I might as well just kind of get that part out of the way. So I'm gonna grab my welding chart over here. And I'm just using stainless steel. This is 1/8 inch stainless. So I'll go stainless steel, W for wire, A8. I think that it is an outside corner joint and there's like it's like a half overlap, so I might not need full 1/8 inch penetration, so I think I'm gonna go with A7. Okay, so I'm gonna start off by going to set program. Click that. A7. Another cool feature of this is like if you want to adjust A7, like the ramp up and ramp down of A7, you can simply go into this menu, plugins, LightBOT, which is our software, and you can go to LightWELD interface. This will bring up the LightWELD interface. So this is where you can like make custom settings and all that. Typically, you'd have to plug in a laptop to take advantage of this with the LightWELD. But we have it all built in. Since we are communicating with the LightWELD through an Ethernet, we can just do this easily. So let's go to A7 and kind of maybe I'll make some adjustments to it. A7. I'm going to start by restoring it so that because I don't know what changes I had made are already on there. And let me zoom in so you can see that. But this is a really powerful. I don't know if you guys use the LightWELD interface, but this is super powerful to be able to do. So this is A7. I'll click restore so it'll go back to its default. Wire feeder is enabled. Ramp up time 100 milliseconds. Ramp down time 1,000 milliseconds. Now those should work fine for what we're doing. Sometimes I'll make the ramp up time really a lot faster, but I'm just gonna leave it at its baseline. I think this will work fine. So here I can, huh?
Does that change A7 just for this program? That changes A7 in the LightWELD period.
This here changes A7 on the LightWELD. So just like on the LightWELD, how if you make a say I go to the LightWELD and I change the wobble frequency and the power on A7, and then if I hold the 2 mode buttons, it'll override the original setting. So that's what you're doing here. You can always restore it. Click restore. Same thing on the LightWELD. If you hold those 2 mode buttons for 6 seconds, it'll go back to its original. So, but this is basically, this, I can do the power, I can do the mode, the power, the wobble frequency, and the wobble length without having to go to this interface. But what I can do here, which I can't do anywhere else, is adjust the gas pre-flow, the gas post-flow time, power ramp up and power ramp down. So I have a little bit more control here. Where this interface becomes really useful is when I go up here to user mode. Now I have up to 20. I can save it as number 0 through 19, 20 custom settings that I can make completely from scratch. This, if you're using standard sheet metal type applications, you're not really going to need this, but if you do anything off the wall, anything really thin, or you need extra weld penetration, or you want your weld wider or narrower, you'll notice, you notice here that you can, these changes, these adjustments here are in hertz and millimeters. So you have exact control over the wobble length. I can make the wobble length of the laser beam up to 5 millimeters. So now the laser beam will make a weld that's 5 millimeters wide, whereas most of the time it's about 2 millimeters wide with any of these settings. So this is really powerful. I can also go here to modulation. Modulation allows me to pulse the laser beam on and off, so I can limit overall heat input. Can also make custom, there's multiple different kinds of settings I can do here. Tack welding, I can adjust the ramp up time, ramp down time, tack time. There's even more stuff here. There's an expanded menu. I can adjust if the laser beam's off center a little bit, I can adjust it there with the wobble offset. This is a really cool feature, power compensation. I'm gonna turn it off here. I don't really need that on. But power compensation, essentially the laser beam wobbles side to side, right? Well, when it gets to the end points of its wobble, it has to change direction, which causes a very slight dwell. So what you'll notice is at the ends of your weld, like in the center, it'll be, how do I say? At the ends of the welds, it'll be hotter, essentially. So with power compensation, you can adjust how much the power goes down at the end of the weld. So in the middle of the weld, it'll be whatever you have the power set to, let's say 1,000 watts. And then if I have 30% power compensation, as it goes to the end of the wobble, the power will go down to 70 or 700 watts. So 30% less, 1,700, 1,700. So then your weld penetration is more even, or you can even pinpoint it towards the center. So you have a lot of really good control by using this interface. But again, I'm trying to keep it simple for this one, so I'm going to go just to A7. I'm going to leave it all alone and just use it as is.
And these are all things you can do with your standard LightWELD.
Yeah, if you plug in a laptop with an Ethernet cord to the back of the LightWELD, there's a section in the manual that tells you how to make them speak. It's using like IP address information. And then, yeah, you can do this on your standard LightWELD handheld. We've done, the other day I welded 1/1000th copper by hand. It was with an XR model. I don't know which one you guys have, but you can do some really wild things by making adjustments in this interface. Another thing I did yesterday was I was able to make one of these welders penetrate all the way through 3/8 of an inch thick aluminum. I'm gonna try to find, I have a video on my phone of that 5,000 stainless that I welded. I'll just show it to you. So that's a 5,000 stainless lap joint. But this is making use of that modulation setting. I was pulsing the laser beam on and off at a very fast pace in order to, control the heat on this 5,000 stainless. So there's a lot of, this is really powerful, basically. It's really nice that it's built into the tablet, because then you don't have to have like a laptop and this tablet. You can just go right from programming, right to the screen, change your setting, go back to your weld program, continue programming. So it's just it's nice and handy. Okay, so we have our weld setting set here. I'm not going to adjust any of the other parameters. That's just the base setting. So the next thing I'm going to do is create a home position. I think where the robot's at now is a pretty good home position. It's up and out of the way. I'm not going to bump into it when I'm changing my fixture. So I'm going to just create a, I always use a joint move from my home position. I'm gonna use a joint move. The reason for that is if you ever program it in a way where the robot gets kind of stuck or bound up in some weird position, using a joint move and being able to click it and move to, it'll move the joints however it needs to get back to that point. So even if it's at an axis limit or it's locked up or something, it'll unwind itself and get itself back home. So it's a good practice to use joint move for your home position, so you could always get back home. Okay, the next position I'm gonna do is kind of just an approach position. I'm gonna not zoom in here anymore until I get to one of the other icons so you can see the robot motion. There we go. Okay, so I'm gonna use the jog feature because I can't reach the robot right now. And I'm going to move the robot, just straight above this point. And then the next move will be down. I like to just get it close, clearing anything that may be on the table. In this instance, there's no, things tall next to the weldment, so I don't have to worry too much about it. And I get my angle of the torch starting to go in the right direction. All right, we'll make that my next point. So this one, I'm going to do a linear move. So a linear move, I just dragged it up into the timeline. I also don't need it to stop at this exact point. I can have it just kind of pass by this point. So there's also another option here where I'm going to make this move continuous. Just click continuous. And I also have speed adjustment here, but I'll worry about the speed later. I'm just going to kind of get the positions in there now. I'm going to slow it down a bit so I don't risk crashing as I'm programming closer to the part. My next move will be just about an inch above the part, and then I'm going to slow down a lot when I get there so that as it approaches the actual weld, it's not, it's going to be moving pretty quick up here, and it's possible that the table may move, and I don't want the, when it starts the weld to have like things moving around or possible vibrations. So I'm just going to go really slow in this last inch here. Let's program a point about an inch away. This is I'm going to also weld at a slight angle because of the way this joint is configured. So I will start and rotate the tool. I'm putting in tool. I'm going to kind of lay the torch over this way, which is going to be an X-axis rotation. Just about like that's good. Do a little bit of Z rotation. This can also all be done by hand. Maybe I should be showing you that. That's one of the beauties of the cobot. So yeah, I'm going to go ahead and save this linear move. And then also make that one continuous. Then my next point, what I need to do is because I'm welding with the wire, I need to go to my wire feeder, feed a little bit of wire and clip it out, clip it right where that red guide beam is intersecting the wire. So let me go ahead and do that. When I click manual feed on my wire feeder, fed out a small amount of wire, but it is, I'll be able to show you this. Okay, so I'm going to go ahead and clip it right where that red dot is because that's where I want the, that's my teaching point. That's going to be my tool center point for this one. So that's
Maybe
about,
show that one tool you make when you're kind of doing this.
yeah, I disassembled it to
okay.
make this, so I can't,
Okay.
but I'll explain it. Typically what I do is I take an extra one of these clamps and the nozzle. This basically just this setup. And then I solder a piece of like, you could use like TIG welding tungsten or a piece of really stiff titanium or something, titanium wire, tungsten's probably the cheaper way to do it. Basically solder it into this piece and then grind it at the right length. Then you have this permanent end effector that you can put on when you're teaching, so you don't have to clip it like I just did. We ran out of stock on this piece, and then I had to send it out to somebody, and then I had to borrow this piece from my teaching nozzle. We now have more in stock, but I don't have that teaching tip set up right now. Okay, so but I'm going to teach basically with the end of the wire. I just need to make sure that it stays at the red dot. So okay, so my next position, I'm going to slow down my motion a lot. So I have it in fine motion. Let's go to 1%. It's funny, this camera, I'm able to see what you guys can see, and it's actually, it might be beneficial for me to use this camera to program, like zoomed in pretty good. Okay, so going down, just kind of finding the beginning of the weld. Right, and basically what I'm going to do is I'm just going to try to just lightly touch the material. I like that. Oh wow, went out of focus. That's kind of how I'm going to teach it, right? Now we can move this robot very slowly, and you can put it in very fine motion. And I'm moving in Z plus right now, so going up, but you can see it's moving very, very small amounts. So this is typically how I would move when I'm getting very close with my programming. And then one trick that I've learned is you can just use the wiggle method. Let's see. Come on, focus. Go. I can just kind of, see if it's touching right there. So I'll go down a little bit more. That seems good. It's very, very close to touching, if not touching just a little bit. So that's going to be my weld start position. So that next position is going to be linear move. This one, I'm going to make the speed very slow because it's just moving an inch towards the part. I'm familiar with centimeters per minute, so that's the unit that I'm going to use. And I'm going to make that motion down 100 centimeters per minute. And that's a fine position. Another thing I like to do is put a comment. Weld start. So if I need to go adjust it, I know exactly which one it is. The one that's following the weld start comment. All right. And now that we're at that point, we can go ahead and put laser on. Use wire feeder. Select your wire feeder. Your wire speed, I'm going to do like 65 centimeters per minute. Not going to use any other auxiliary device. Now, I don't really want it to wait at the beginning of the weld here. I want the laser is going to ramp up over the course of 1/10 of a second, and I don't want it to wait any longer than that. So I'm just going to put this, at 1/10 of a second to match the weld program. The 1 second gas flow pause is good. Let gas get in that area. All right, and then it's on to the next point. This weldment is very easy. It's just 2 points. So my next one's just going to be, I'm just going to simply move up.
You not just do that manually though? Just put it into the
Yeah.
sheet?
Yeah, let me show you that. I forgot. I always jog. That's just kind of my preference. But yeah, let me show you the manual motion.
Are you jogging because you found that it's faster and the best way to do it? Or are you jogging for another reason?
It's just kind of personal preference. I think I got, when I do the large motions across the table, like when I'm going from home to over here, the jog is faster, I think. But when you're positioning the torch, right? So you're getting the torch at the right angle, it can be really handy to, put it in freehand teach, and I can, dial in my angle a lot easier like this than with jog. I'm not exactly sure why. I just prefer I understand, like my mind really wraps itself well around the XYZ axes, so I can just be like, okay, X, Y, Z. And also this big robot, it's difficult for me to reach when it's up and out of the way. So I just kind of gotten the habit of using jog. But yeah, I can definitely use jog, so I will do that here. Let's zoom out. So right now I have it in free mode, which means that I can move any axis however I want. One good one is translation mode. So let's say like this is the torch angle I want. I can put it on translation mode, and then no matter how I move it, that torch angle remains. So that would be really good if you went from, say, the start position, put it in translation mode so the torch angle doesn't change, and then you move to your end position. So that's what I'll do, actually. I'm gonna go ahead and put it back to the start position, activate translation mode, and then move it that way. So I'm gonna go to the weld start position. I'm gonna do move to. It's moving to that first position there. And then I'm gonna go to translation. Oops. See, a lot of times I'll just lock out this screen tilt because I prefer to use it in the upright. Okay. Freehand mode. Over here. Now, when I get close to the part, I really don't want it to be able to move fast. So I'm going to slow it down, make it very, very heavy weight. So that way it'll move very, very slowly. Because otherwise, if I, say I pull too hard, I can crash into the part. Might be another reason that I got in that habit of using the jog mode when I'm teaching precise points. But this is definitely faster than the jog mode.
Question is the difference between a cobot and just sticking a light weld on a regular robot. If you're programming like we do with a normal robot with a cobot, then you're actually going slower anyway because you're more inhibited, but I don't know if you can work in the same space.
I think even the programming with the jog and the way that the icons are with the CRX robot, I think is still going to be a lot faster than programming with the traditional teach pennant. You can do that here too. Like let's say you're familiar with Fanuc, the traditional type programming. All these icons are just in the background making your standard robot program. Watch, I'll go here. File. Bring up the legacy teach pennant, edit. There's the program we just made, or what we started with so far. So, right, you're doing the same thing. It's just you don't have to type any of this or select from menus and menu. You just drag an icon and drop it. But yeah, the handheld movement is a nice thing. You know what it did for me is, when I started using this, I didn't have robot experience at all. So what being able to move this by hand did for me is allow me to learn how the robot moves a lot easier. I gained an understanding of what joints move when it moves in certain ways by grabbing it and moving it. I know what it doesn't do. I know, the limits of the axes a little bit better just because I'm tactile, right? I work I learn with my hands by doing. So that helped me, but I just found myself jogging more often. Okay, so I've moved it to the end position there. Double check it. Yep, it looks pretty good. So I'm going to go ahead and then just drag another position icon. And the exposure gets messed up unless I'm right on the screen. There we go. All right, it's just a linear move across the edge of that part. The speed that I want to go, I'm going to match my wire speed. So I think my wire speed was 65. I think I need to go just a little bit slower than the wire speed. So let's go 62 centimeters a minute. And then after that, we will do a laser off. I have the laser ramping down over the course of 1000 milliseconds, so 1 second. So I'm going to give this a little bit of extra time. So I'm going to give it like 1.5 seconds. And then after that, we use a laser off confirmation. And this is just like an overall timer at the end to let the LightWELD finish all of its processes. I typically give it like an extra whole second. So that way any, gas post flow can finish before the robot moves on. Because if you move away and the gas post flow is not done, you may get a spot of oxidation at the end. But the reason we have adjustments here is because you can adjust that in the laser setting on the LightWELD. If that was a fixed value, then there would be no need to adjust these. But basically, you need to look at and see what that ramp down and ramp up timing is, and then you can make your adjustments for these timers here. Okay, and then my next move is just going to be up and away from the part. Okay, I'll do it manual again. All right. That'll kind of be my unapproach position. Save another point there. That can be continuous and it can be pretty fast. And then I'm going to copy paste my home position. Copy, paste. All right. So that's my weld program right there. Now what I'm going to do next is I'm going to clip this wire short, and then I'm going to do a dry run just to make sure that everything is going at the speeds and the positions that I expect it to. So there's a option at the top here for weld enable, weld disable. I just call it dry run. So as you can see, weld is disabled here. And click that, allows you to enable or disable. I also need to dry run it. I need to deactivate editing, open the play menu, and then I can select the speed at which I want it to run. I typically do like 75% on a dry run if I'm confident, and then I just have my hand ready here in case I did something wrong. Okay, so I'm going to go ahead and play that. And what I'm going to be looking for is I'm going to be looking for the position of the guide beam, the little red dot, to make sure that it's on the correct position. What's really good about the robot is just the consistency. Like you guys were saying, handheld welding, you could be pretty consistent, but you're never gonna do as consistent of a speed as what this thing can do. All right, that's an out of the way. I think what I want to do is maybe add a slight longer pause here at the end. So you can either use that laser off confirmation, or sometimes there's this wait command. And somebody brought a good point to me at one point. They said I always use a wait command at the beginning, right before the weld, and at the end after the weld. And basically at the beginning, it'll allow any vibrations in the table to settle before the weld begins. And at the end, it can just, be used if you need it for the post flow. So I'm going to go here and edit And then right before the laser on icon, I'm gonna put a wait, give it, yeah, 2 seconds just at the start. And then at the end, give it another 2 seconds. Not absolutely necessary, but it's just kind of something I got in the habit of doing. Okay, so I'm fairly confident with that. So I'm going to go ahead and just run the program. I'm going to activate laser on, and I'm going to throw on my laser safety hood. I have the glasses on already. Doors closed, laser's on, gas is on. We'll activate the weld enable. And go for it. You guys ready? Hit that as a yes. Okay. Run. I'm just covering the e-stop in case there is some mistake that I made. But I think it's going to be pretty good. Maybe a little bit much power. I could probably go down in power a bit. It's burning through the back pretty heavy. But overall, it looks like it's working really good. Well, I'm also thinking that the part is moving. Yeah, the part was just moving a little bit in the jig, so it moved away from the wire. As I was mentioning, I need to make these clamps a little bit more robust. But anyways, for the most part, that was really good, especially for a first run at it. I think you can probably see even that these toes they were moving apart, so it broke. Basically, the wire was feeding into nothing, or not where it was programmed at least. Okay, so let's go ahead and look at this. So I think what I would do, over penetrating. So what I would do is I would, because I'm feeding just an 060, or sorry, an 045 wire, I would increase the wobble quite a bit, right? So that I can fill that in more. I'm getting good root penetration, right? But I want to fill in this top bit more. So I'm gonna increase the wobble. And then yeah, this was like a half overlap before. Now it's like exactly a corner to corner. So it's definitely opened up and moved away from where it was supposed to be. Okay, so let me do another one.
Increase the wobble, does it also change your travel speed, or does the travel speed that you have set to the robot pretty much override everything?
The wobble doesn't have anything to do with the travel speed. It's just the width of how wide that, the galvanometer in the gun is making the laser go like this. So if you make it wider, it will take away some penetration because you're moving that energy around a wider area. But in this instance, I was over penetrating anyway, so widening it should only help. But the travel speed of the robot is just whatever you tell it to be. And then I think I'm trying to figure out a good way to keep this from moving on me. Maybe I should just kind of give this one a pre-tack, but I don't know if I have that ability, or I can't take the fixture off because I moved it'll move the points. We'll just run it again. That may happen again. Keep in mind, this fixture is not optimized that great.
Program in a tack on the front and the back, and then go back and do your weld, just add a tack into your program
Yeah.
now.
Yep. Yeah, that is a good idea. I can do that. Let's do that. All right, so I'm gonna deactivate weld, enable editing. And then I'm going to move the robot. I need to clip the wire now. And the robot towards me.
Well, two of our team are or three of our team are pretty good at moving, programming robots. Dave, who's a welding, he's the operator of this. He's probably spent most time on the LightWELD. How long do you think would you be able to get him up to speed with this icon-based programming pretty quickly? Would you say, like on your day of setup for him?
Yeah, I mean, normally in the past when customers have bought these and they've come in for training, um, well, first off, when the machine gets set up at your location, typically whoever's doing the setup is going to give some basic training on just kind of how to use it, how to move it, how to do the things. But when people come over here for additional training, typically a day is enough. Obviously, you're going to have to take some practice with it and sit down and and learn it a little bit more. But as far as like how to do this, how to move the robot, how to adjust settings, it's very easy, especially if you know how to use the LightWELD. I'd say most of the people that we've trained on how to use these didn't have a robot before. Um, this is most of our customers are probably getting these as their first robot. Um, and yeah, they're up and running with just like a day's training. There's been a couple of really tricky applications that maybe would require some more, just because it takes them a little bit more to figure out, the right settings and travel speeds and stuff like that, because they're, either dealing with something really thin or some more complex movements. But like, what are you guys working with? What is the main thing that you guys are working with? Aluminum. Aluminum is actually really forgiving with this. The weld pool becomes very fluid, and it seems to be a little bit more like forgiving with the programming. What I've noticed, this one, let's say, the weld pool is very localized, whereas where the laser beam hits it, so your position has to be like real perfect. The aluminum, the way that the weld pool grows a little bit more, tends to be a little bit easier, in my opinion. But yeah, we'd be able to teach somebody how to use it to the point where I think they should feel comfortable going back to their shop and just having at it within a day for sure. Obviously, practice is going to make it more perfect though. And there's classes available, Fanuc programming classes. The main thing to learn really is where to use the icons, how to adjust them, how to move the robot. Anything more in depth with the Fanuc, there's a lot of information out there available about how to do that. Okay, so let me make a couple of adjustments here. One, I noticed that the laser beam is not perfectly on center, so that could have also maybe caused something. So let me go into that LightBOT interface and make a slight adjustment to the centering of the beam.
That of it because you had changed something that it wasn't on center, or would that happen on a regular light weld?
Oh yeah, that can happen on a regular LightWELD. It may be because I just assembled this piece and I haven't used it since. So if this nozzle is like clocked a little wrong, and then the wire is going through the nozzle at a little bit of an angle, then the laser beam stays the same. But if the wire is a little off, it can be off. Basically, the laser's not hitting the wire right in the center, which is what you want. So it's probably due to me not testing this after I assembled it yesterday. With the handheld LightWELD, it's a little bit more likely to happen, just because you're more likely to bump it into things, or you take the nozzle on and off more often, possibly. But yeah, you can adjust. You can actually do that beam centering on the LightWELD without any computer. If you go into setting Y0, so instead of like A, C, E, whatever, you go to Y0, And then you set the bottom. No, you just go to Y0 and then the wobble frequency adjustment will center the beam. So it's really handy thing to know how to do. So I've just adjusted it. The beam is much more on center now, so this should be better. Yeah, and I'm gonna go ahead and do a tack weld at the beginning. I'll probably just use Fusion for the tack weld. Typically, I like to use Fusion whenever I'm doing a wire weld over it because I don't want there to be a bump on the joint that the wire has to run over. So what I'll do is I'll just kind of still use this to teach it, but I'm gonna just not feed wire when I actually go to do those welds. I'm gonna look at this weld real close, see if there's any adjustments I need to make other than that. That's pretty good overall. Maybe a little bit of extra length. That's right, 50% increase in length.
Wobble up on that. Are you able to catch that outside leading edge and blend that into the weld?
Mm-hmm. Yeah, I don't know if I'll be able to do it with a factory A7 setting because it only can go up to plus 50% width.
Okay.
But definitely if I made a custom setting, I can just go wider. I can go up to 5 millimeters. Maybe I'll just do that. Let's just make a custom setting. So I'll show you how that looks like. When you need extra width on the weld, this is just what you have to do. Okay, so let's make a custom one. Sorry, it's sideways. User. Let's just save it as number 10. So 1,000 watts. The last one was 950 and it was a little over penetrated, but I'm also going to widen it more than double here. So I think 1,000 watts should be okay. And then we'll make it 5 millimeters wide. Wire feeder enabled. This is just a total custom setting that I'm making here. And I'm just going to save it. Then when I go back to when I select program X 10, user 10. And so it's just going to call up that program instead of the other one. So I need to basically put a tack program, put the tack here. So I'll put a comment so I know where to put that. Here. T1. And then also T2. Okay, so move to place the approach position. Actually, no, we'll move to the weld start position of the other one. Or not the weld start, the one that's 1 inch above. That's where I'm going next. Okay. Oh man, sorry, the camera. Every once in a while, the camera just kind of does whatever it feels like. Let me go back down here. There's another thing I didn't point out to you. Yeah, I have this tool balancer here. It's real good for the wire feed because you want the wire feed's path to be nice and smooth. I think maybe I need to loosen it a little bit, but yeah, this is a really good way to do it. It's like hang a tool balancer for the wire feeder, or you could even do the LightWELD conduit. It's up to you. But the kit is provided with these Velcro straps. Man, what the heck? Sorry. Not sure why the camera does that.
There's a bunch of robots in there.
Yeah, we got a couple of them. So one of these was is one that we are trying to bring back to life. This one was on a trailer and it was not transported in its proper position. So there's a special transport position that you put it in so like it's real tucked up and its center of gravity is centered. Well, somebody transported this with the arm just completely extended in like in some weird position. And like they drove thousands of miles like that. So it got a little bit of abuse. So I just brought that one back to life the other day. And then this is just our smaller demo robot, which we use. This kind of has our, like the mount on it that holds the gun is like the first revision of it. Or I think it's the second revision of the mount. We just use this for like testing and, program development. And then just based on the positioning with the camera, this one becomes the best one to use for demos here.
You will cover most of that table with the arm on that. Is that a 6 foot extent or a 6 foot arm on your below reach?
Yeah, the table works really nice. For this robot, I can't really show you, but for this robot, we cut like a 1/2 inch or 3/4 inch thick steel plate, and we tapped holes in it to mount the robot. This robot's like 300 pounds, so we want it to be a little bit more heavy duty. And we wanted the most use of this space, so we actually use these angles that come with the segment table, and we bolted them on the side and then bolted that plate onto these. So that way, the robot, isn't taking up any of the table space with its own base. So we can effectively have the most table space available to us. And then on the smaller robots, this one is just temporary. So I just use these, thumb lock pieces. But again, it's like a 1/2 inch thick steel plate. We bolt the robot to that with these guys. And then we just have the hole pattern cut so we can use whatever holes we want with typically we want to use a bolt, a nice heavy duty bolt. But for this one, just for me to work on it temporarily, these little thumb wheels are real handy because I can just lock it down quickly like that. These don't tighten enough though. Like say the robot does a really rapid movement change, this can possibly move on the table. So you want to bolt it down. Yeah, you can, also with these robots, like if you were to buy one and tell us like the whole spacing, we could easily cut you one of these. Maybe you guys have the capability also, but we've done that for quite a few customers. And these are just not since we're over here. That plastic thing on the left and those other ones are just some jigs that I've used for various different welds. You can see this one's real simple. Just using rubber bands to hold this part in place. Try to make it as simple as possible. This is a part for like a knee splint. And then, yeah, so especially like this one was like one of the ones that we didn't use contact with the LightWELD. So this, didn't really need to be very sturdy because we weren't touching it. It all looks organized over here, huh? Not over there. Okay. All right. So let me go ahead and finish adding these tacks in here so we can get this one going. Okay. This one is I wonder if this part might have a little bend in it. I really need some clamps that kind of press it here. There's like a gap here. But we'll just go for it anyway. So I'll just do manual guided again. The wires a bit long. Slow that down. That'll be a good spot for attack. I'm gonna go into the tablet. There. Slow it down a bit. Set program. And I'm just gonna use a factory tack welding setting. So stainless steel A5, maybe 650 watts. A5, 650. And then laser on. I'm not going to do any motion here, so I'm going to enable fusion lock. I'm not going to do any motion, so I'm going to do a wait command. And I don't know exactly how long that tack is without going and looking at it. So I'm just going to give it 5 seconds just so that I don't give it not enough time. Wait, not 50, 5 seconds. Laser off confirmed. It's not going to take 5 seconds, just so you know, but I'm just I'm just giving it extra because I don't have that data right in my head. Okay, so that will be fire the laser there. I'm going to move this program set icon because I'm going to use this program for this weld here. Oops. Before the linear weld, and then I basically do the same thing again for the end of the tack at the end. Hope I'm not confusing you guys. I gotta speak while I'm doing things sometimes so I can think. Okay. A good spot for attack at the end. Um,
You are able to program fusion in the middle of your wire feed just by
Mhm.
programming that step, doing the
Yeah.
enable.
Yeah. Yeah, and then after every weld, like with the wire retracts so that if you have a fusion weld next, then it won't be in the way anyways. Hmm? Say something? All right, so I think we should go ahead and dry run it. So I got all those points right first time. Wire off. And we'll dry run it. Oh, I have that point too slow. Stop that, and then we will make that a bit faster. Oh no, you know what? I have one position in the wrong spot. This. Right over. Change the tack setting, which is good. It's waiting 5 seconds. Moving up. Okay, that one can be faster. Tack, 5 seconds. Move it off, up. Okay, now that one can also be faster. I'm able to just kind of adjust it as I'm doing the dry run, or pause it, make some adjustments. Everything else should be good, but I'm just going to verify that my positioning is on. I think the last thing I want to do, I think maybe the endpoint, I might have programmed the endpoint too high. So I'm going to just kind of check that one. That might have also, it could have been the reason that it failed at the end the first time. I might have had maybe the wire was a little too long when I taught it. I'm just going to feed some wire out, clip it, double check. This is kind of my process of troubleshooting, right? Like when I'm first setting something up, if I have troubles like I did on that first one, I'm just going to go through, check a point. Once I get it dialed, it should, as long as the part's repeatable, it should be pretty good. Okay, we'll move to this point. Oh yeah, my point is off. Probably the wire was too long when I taught it the first time. So that's got it. What it was happening was the robot was moving away from the part as it went from here to here. That's probably the actual cause of the issue the first time. Let's touch that up.
If the fixture is made properly, did you double check that by looking at the C position at the start and the end of that weld?
Sorry, can you repeat that one more time? Sorry.
If your fixture is set up properly, could you have double checked the height of that by the C position at the beginning and the end of the weld?
Yeah, if the fixture was set up properly, I'm sorry, I'm a little unclear. So you're just saying, can I just move to and verify before I run the part?
No, so when you said that might have been a little further off the part, when you were setting it up initially, if you'd have looked at the Z position at the start of the weld and then the
Oh.
Z position at the end of the weld, would that have indicated that those were probably off by a certain amount?
Probably, yeah, that's a good idea. I can just look at the data here. If the fixture is nice and flat and the parts are flat with the
Right.
table, then yes, yeah, definitely. Let's just do that before I click touch up. Let's check. So our start position. The Z is, here, you help me remember. Negative 167.5. Negative 167.5. The end position. Yeah, negative 167.1. So it is off a bit. But I think also it could have been that it could have just been caused by the fact that when I moved to the second one, the wire moved a slight amount. It wasn't that much. That's not that much of a difference though, half millimeter. But I guess it could make a difference. Okay, so let's touch up the last point. Touch up, okay. So now it says 168.3 for this one. And the other one, start was what? Start was 7.5. So it's about off the same, just in a different direction. So it was probably just my positioning. I bet maybe I should check the first one. Let's check the first one again. Let's start. Move to. The first one's pretty high too. It's probably my wire was stuck out more than I expected. That's why it's good to make like a fixed teaching tip. That way this is not a chance of this happening. All right, yeah, we'll go there. Touch up. So now they're very close, both negative 168 point they're within 0.2 of a millimeter. So, okay. Now that I'm confident everything is set up properly, I'm gonna go ahead and clip this wire. Get ready for the beginning of the program. And I'm gonna go ahead and run the weld again. Make sure my parts are flat on the fixture. All right. Not too much of a gap for the tack weld to work. Should have known that. Really, the one at the end is the one that matters here. You see a much larger path of the laser beam. That looks really nice. No, it's hard to see on the camera, but once it's finished, you'll see. And it looks like the positional points at the beginning and end are they're helping a lot here. Perfect, perfect. Okay. That went really well. Zoom in now. Camera. Maybe I need to adjust the power a little bit at the start and the end. Typical, easy to overshoot the beginning and the end. Right. You see, I was able to capture that corner by using 5 millimeters weld width.
I were playing with that by hand, which is one of the challenges to get that consistent profile.
Yeah, this one, This one looks real consistent. Not sure how well you can tell on camera, but it's, if you wanted to make that a radius, you could just lightly sand just where the weld meets the,
What's the inside of that look like, if we could?
so I'm looking up close here. And it's not quite penetrating all the way through, but it's very close to doing so, it looks like. So definitely with that increased width, it could go along with either slower travel speed or what I recommend is just a little bit more power instead.
You change nothing, but just bump the power right up now to 1100 and you see if it'll weld one real fast.
Yeah, I'll do another one.
That'll show us how fast the next part would be.
Okay. Yeah, let me, I might go up a little bit more just to make sure that it's gonna get the penetration. Because, just in case 100, doesn't do it. I did double the width of the weld, more than